Today I am going to take a friction chapter. So what is a friction? So the friction is a property related to the two surfaces in contact which oppose the relative motion or tendency to move between them. So friction is due to interlocking. So suppose that this is a one surface and this is another surface. This is called interlocking in solid. Interlocking in solid. In case of liquid, they are called viscosity. In solid you can say friction, and for liquid you can say viscosity. So how many type of friction you have? There are two type of friction. Two type of friction. One is a kinetic friction and other is a static friction. Okay. What is the formula for the friction force? So the general formula for friction is mu into n, where mu is a coefficient of friction, and n is a normal reaction force. Okay. Now discuss in detail. So what is a kinetic friction? So the kinetic friction you can write F K, this equal to mu K into n. So mu K is a coefficient of kinetic friction. So mu K is a coefficient of kinetic friction. And in a static, okay, so first, what is a normal reaction force? And kinetic friction only act when two particles in motion. So suppose that you have ground and the one mass m mass is moving in this direction v. So the tendency of friction force in opposite to relative motion. So this is the frictional force, always opposite to v. Okay, and that friction force is called mu into n. So suppose that here mg will act in downward direction and the normal reaction force always act perpendicular to the plane. This is a very important point. So the perpendicular to the plane is a normal reaction force. So there is no motion in vertical direction. So n equal to mg. So you can write here frictional force equal to mu mg. But general formula of friction force is a mu into n. Okay. When particle in motion, then you have to write friction force become kinetic friction, that will be mu k into n. Now let's discuss about the static friction. So static friction, it means particle is not moving, just tendency to move. So that is a static friction. So some book and many places you have seen, so static friction, if you write mu s into n, where mu s is a coefficient of static friction. Okay. Here I have some modification about this. So static friction is equal to mu s into n, but what is my thought is a maximum static force, static friction force Fs, and you have to write maximum. This will be mu s into n. Okay, so this is very important, because in many book, many material I have seen, the static friction is written friction force equal to mu s into n, but the maximum static friction force is a mu s into n. Not always static friction is a mu s into n. Let's one example. Suppose that you have one particle is kept here and mu k is a given 0.3 and mu s is a given 0.5. So one more important point, mu s always have a greater than equal to the mu k. This is also important point. Okay, so let's suppose mu k is given 0.3 and mu s is given 0.05 and here 2 kg. Just take a let's 5 kg mass. Okay, 5 kg mass you have. Okay, here you have friction and applied force is a 10 Newton. Okay, so what is now friction force? So first you have to check what is the maximum static friction force. That is the first step. You have to check Fs maximum. So if your applied force is greater than the Fx maximum, then it will move. Then you have to think about the kinetic friction. So let's first find out what is the maximum static friction force. So maximum static friction force equal to mu s into n, that equal to, you can write mu s into m into g. What is the mu s here? Mu s equal to 0.5, m equal to 5 and take g equal to 10 here for the simplification. So the 5, 25 and 25 Newton. Okay, so if you applied force is more than 25 Newton, then it will move. So now what is the friction force? So this 25 Newton is a maximum static friction force. That is not a static friction force. That is very, very important here. So because this you are here, you are applying 10 Newton force in the right direction, then particle will not move. So the acceleration equal to 0. So now think about, so what is the friction here? Let's suppose that friction is a Fs. I don't know what is the value, but acceleration is 0 because applied force is less than maximum static friction force. So acceleration is 0, so you can write 10 minus friction force, this equal to mass into acceleration, that will be 0. So the static friction force equal to 10 Newton. So that is the point I said here, maximum static friction force is a mu s into n. If your applied force is greater than 25 Newton, then the friction will be static, but before is a applied force is a static friction force. So now you can write the general statement, if you applied force is a less than and equal to maximum static friction force, maximum static friction force, that is a, if you applied force is less than mu s n, okay, then friction force, then a static friction force equal to Fa. So very, very important, not mu s n. Okay, when Fa is equal to, okay, first go for only less. Okay, if Fa is equal to mu s n, then you can say frictional force is equal to mu s n, or same Fa equal to mu s n. If the applied force is greater than mu s n, then particle in motion. Okay, then particle is will be in motion. Then the frictional force called kinetic friction force, that will be mu k into n. So these are the very important point. You have to always how to use the formula for friction force. There are two friction force, one is a kinetic friction force and one is a static friction force. Okay, kinetic friction force is very easy, just you have to write mu k into n. Okay, and mu k is a coefficient of kinetic friction. But in a static friction, little bit complicated here. So if you write a static friction formula mu s into n, so that is not always mu s into n. So that is a maximum static friction force, that called mu s into n. So how to find the static friction force? Then you have to calculate first what is the Fs value. So this is the maximum 25 Newton. If your applied force is a less than maximum static frictional force, then your static friction will be applied force. Like example here, if I have calculated already what is the maximum static friction force, is a 25 Newton after using the mu s m n formula, and now you are applying only 10 Newton, then particle will not move. So the friction force always equal to here 10 Newton, because net force must be 0 here. So now the general formula is a, if you applied force is a less than maximum static friction force, then the static frictional force equal to applied force, not mu s into n. And if your applied force is equal to maximum static friction force, that means object is almost about to move. So that time you can write Fs equal to mu s n. This is the maximum static friction force that time. If Fa is greater than mu s n, then particle will be in motion, and then friction will be kinetic friction, that is equal mu k into n. Another important point. So the friction force does not depend on the contact area between the two parts. Okay. See here example. I said what is the statement here? So the statement is frictional force is independent of area of contact between two objects, between two surfaces. See, so suppose that I am going to draw here two cases. First case is like this, you have okay, and here this is the friction, okay, and the mass is given here m, okay, and another one is here contact area is more, so this you have, this is also mass m, okay. Now here contact area is more here A2 and here is A1, so the A1 is less than A2, and of course suppose that there are same material, this and same material, so now we have mu is the same for both the cases, okay. Now let's find the friction force. So here mg will act in downward direction and normal reaction force in upward direction. So here n equal to mg, similarly here also mg equal to n, so here also n equal to mg. What is the friction force here? So the friction force equal to mu into n, that equal to mu into mg, and here also the friction force equal to mu into n, that is a mu into mg. So you can say here friction force is exactly same, but you can see the contact area is here large. So friction force is independent of area of contact between the two surfaces, only depend on the mu. Mu is also independent of two surfaces, to contact area of two surfaces. It only depend on the property, which type of you have two, one like this, and if you have another, which kind of interlocking you have, that is and generally if you have a same material like glass, then you have maximum frictional force, and if you have a different material like one is a glass and another you have wood, then you have minimum frictional force, okay. So let's draw the graph of frictional force for, if you have a given in the question, now this is the block is kept here, mass is given m, applied force is a F, that is a alpha into t, where t is a time, alpha is a constant, t is time, okay. So find the, and here given mu s and mu k is a coefficient of static and kinetic, okay. So now, okay, so go for what is the frictional force, okay, with respect to time. So what was the here from general formula? If the applied force is a less than maximum static friction force, then the friction force will be equal to the applied force. Now you have to find what is the maximum, Fs maximum. So maximum static friction force, that will be the mu s into mg, mu s into n, and n here you have mg. So you can write mu s into mg, okay. So the formula is a when applied force, okay, what is applied force? Let's find the F equal to given applied force equal to alpha into t. Let's see t naught, that time this force is a mu s mg, okay. So the applied force is equal to the maximum static friction force. So what is a time that time? T naught equal to, you can write mu s mg is by alpha. So now we have to write friction force frictional force equal to, let's see, when T is a less than T naught. So now you can say here applied force is a less than maximum static friction force. Okay, because at T naught you have applied force and maximum static friction force are equal. So when T is a less than T naught, then what is the formula here? When applied force is less than the maximum static friction force, then friction force will be equal to the applied force. So what is here applied force? That is alpha into T. So you have to write alpha into T. When T is equal to T naught, that time you have maximum frictional force, that is called static friction force. So mu S mg, or you can write alpha T naught also, but it is a constant. When T is a greater than T naught, okay, then particle will move. So then what is the friction force? That will be the kinetic friction force. So mu k into mg, that is also constant with respect to time. So how to plot the friction force with respect to time? So let this, you have time, and this is the frictional force. Okay, so if you take T less than T0, then alpha T. So alpha T, it means this is a straight line with slope alpha. So suppose that this is the, you have T naught. Okay, so this is alpha T up to here. Okay, so this is the alpha into T, and you can, this is the angle alpha, sorry, alpha equal to tan theta, this angle is theta. Okay, when T is a greater than, see, when T is a equal to T naught, that time mu S mg. So you can write this one. This one is a mu S mg, or you can write alpha into T naught. Both are the same. Okay, and after that, if T is a greater than T naught, then mu k mg, and mu k mg is a less than mu S mg, but this is also constant. So if T is a greater than 0, then you have slightly less. Okay, you have to go little bit and this. Okay, and this value, if you see here, this you have to write, take the other color. So this will be mu k mg. So this is the graph you have. So the first, before T naught, friction force is only equal to the applied force, and then it will reach at the maximum static friction force at T naught. When applied force is equal to the maximum static friction force, then the friction force will be kinetic, because applied force is greater than maximum static friction force, the particle will move. So this is the graph you have between friction force and time. Okay, let's find the, in the lift, suppose that if you have a one lift, and inside the lift, one particle with mass m is moving with velocity v in this direction. Okay, and lift is going with acceleration a in upward direction. Okay, what about the friction force? Here given mu s and mu k. Okay, but moving here, so mu, you have to take mu k, because particle in motion. So of course friction force will act in this direction. So what is the magnitude of friction force? That you know, mu k, because it is in motion, into normal reaction force. What is normal reaction force? So this you have to write mg, and upward is a n. So either you have to apply the pseudo force concept, other than you just write the Newton's second law, net force. Where is it going? Upward direction. So then it will be greater than mg. So you have to write n minus mg, net force equal to mass into acceleration. So the n equal to mg plus a. So what about friction force? Then friction force will be mu k in m into g plus a. Okay,